This lesson is about negative exponents. Let's look at the definition first. If a is a real number, 17, and a is not equal to 0, and n is an integer, negative 7, then a to the negative n is equal to 1 over a to the n. Now what we're going to do is figure out why. Why does this happen? So let's say I have 5 to the third over 5 to the fifth. If I write that out longhand, it'll be 5 times 5 times 5 over all these 5's multiplied by themselves. Now when I go to divide it out, don't forget the number that's left is the number 1. So I end up with 1 over 5 squared, right? But if I use that quotient rule that says when you divide numbers of the same base, you subtract their exponents. So this will become 5 to the negative 2. So 5 to the negative 2 is 1 over 5 squared. If we didn't define it like that, you guys, math as we know it would crumble at our feet. So let's do a couple of examples. Yeah, let's. So the first one, I always think of this negative exponent thing as more like a reciprocal. So let's do it. So this first one here is 3 to the negative 4. Well, that's 1 over 3 to the 4th power. Now, 3 to the 4th is really not that hard to figure out, so let's evaluate that. That's going to be 1 over 3 multiplied by itself, a total of 4 of them. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So that'll end up being 1 over 81. In general, you should multiply out those bases if you can up to the power of 4, and then beyond that you can just write it regular. Now let's look at B. This is a little review of fractions. So here we go. 4 to the negative 1 using the definition will be 1 over 4 to the first. 2 to the negative 1 will be 1 over 2 to the first. So we're adding really 1/4 and 1/2, which is you can get a common denominator of 4. So we get 3/4. You baking enthusiasts in the crowd probably could just jump right from here to here without doing any kind of common denominator thing. Okay, let's take a look at C. Well, remember what a number to the 0 power is always 1. And then 2 to the negative 3 is really 1 over 2 to the third. Well, 2 to the third is 1 over 2 times 2 times 2, which is 8. So this turns out to be 1 1/8. You could write it as an improper fraction as 9/8. Now let's do the next one. Okay, a little bit more evaluation going on here. I'm going to show you a couple ways to do D, because I want you to pick the way that you like the best. So first thing you could do is subtract your exponents, and you get x to the negative 5, and then use the definition and make it 1 over x to the 5th and be done. The other way to look at it is this, and I kind of like this way because as your problems get more complicated, it's easier to visualize. So like I look at x to the 4th, that's really all these x's multiplied together, and x to the 9th, oh boy, I gotta write it out. 5, 6, 7, 8. And so what I'm going to do is I'm actually going to cancel 4 of them out, and I have 5 left over, but where are they? They're on the bottom, so it's 1 over x to the 5th. So I say, how many of them are going to cancel, and where are the rest remaining, and how many of them are there? Okay, let's do the next one. If we think it's y to the 4th over y to the 5th, well, that means we have 4 y's on the top, 5 y's on the bottom. 4 of them are going to cancel out. I'm left with a 1 on the top, so I get 1 over y. Thinking 4 are going to cancel out, there's going to be 1 left over, and it's going to be in the denominator. Boom. The other way to do it is say this is really y to the negative 1, which becomes 1 over y. So either way you slice it, you get the same answer. Now let's look at the next one. The next one, see how big they're getting? So that's why I want to think about it as canceling them out and figuring out where the other ones are going to be. Well, let's take a look at negative 5 over 10. Well, that's really negative 1/2. So I'm just going to write that there so we can deal with it. Now let's deal with the x's. I have 8 x's on top, 3 on the bottom. That means 3 are going to cancel. Where are the 5 going to be left? Y on top, because we had more on top to begin with. Y to the 11th over y to the 13th. 11 of them are going to cancel. Where are my remaining 2 going to be? Answer, on the bottom. And how about z squared over z squared? Well, they're going to cancel, right? I'll have 0 z's left. I don't even have to write it. Now, you could actually write this answer like this, just with the plain negative there. Let's take a look at G. The first thing I want to do is write everything in terms of positive exponents. So the 4 is golden, stays where it is. S squared golden. The s to the negative 5 goes downstairs as x to the 5th. So whenever you are encountering a negative exponent, it moves. If it's the negative exponent in the denominator, it goes up to the numerator as a positive, etc. Now, let's finish this off. I have 2 s's on the top, 5 of them on the bottom. 2 are going to cancel. I'm going to be left with 3 of them on the bottom. Cool? Then I don't have to really deal with any of the negative exponents anymore. H, see how complicated they can get? But never fear, we can do this. So this is how I want to do it first. I'm going to raise everything to the 3rd power, move negative exponents around, then simplify. So raise everything to the 3rd power. Here we go. It's going to be 2 to the 3rd. When you raise a power to a power, you multiply your exponents. So x to the 12th, y to the 9th. In the denominator, it's going to be x to the 21st, y to the negative 3. Now, I want to move any negative exponents. So I only have one negative exponent here. Anytime it's a positive exponent, the thing stays where it is. So 2 to the 3rd is 8. X to the 12th is going to stay where he is. Y to the 9th, stay where he is. X to the 21, stay where he is. Y to the negative 3, oh, he's going to come up top as y to the 3rd. And now we're going to just figure out how many y's we got, how many x's we got, and be done with it. So this is going to equal 8. What about the x's? 12 of them are going to cancel. We have 21 on the bottom, so the leftovers are going to be on the bottom, and there's going to be 9 of them left over because 9 plus 12 is 21. But look at the top here. I have 9 y's on the top and another 3, so a total of 12 of them. So we're combining them. And that's it for that one. Want to do the next one? Yeah, let's. So we're raising a power to a power, move stuff around, simplify. Powers to power, move stuff around, simplify. Here we go. So power to power will be 3 to the negative 3, x to the 6th, y to the negative 15. Because we're multiplying our little happy exponents. Move stuff around. 3 to the negative 3 goes on the bottom as 3 to the 3rd. X to the 6th doesn't move because he's positive. Negative things want to get their lives better, so they move to a new location. Okay? Positive things stay where they are. And what about this guy? Well, he's negative, so he needs to move to a new location. So it's y to the positive. Now he becomes positive. And the only little thing left to do is actually multiply out 3 to the third and get 27. Now you'll be able to do the lesson associated with this mini lecture. Good luck, stay strong, ask lots of questions.